Space, the final frontier. It beckons us with mysteries, with stars scattered like diamonds on black velvet. We long to understand its secrets, to unravel the very fabric of the universe. This quest for knowledge leads us down exciting paths, constantly pushing the boundaries of what we know. Hey everyone! Welcome back to the channel. Today we're diving into something mind-bending, a personal project I've been obsessed with for months, the Tosh Metric. What if I told you this could redefine how we understand space-time, travel between planets, or even unlock secrets of the cosmos? Let's break it down. Today, we stand on the verge of a fresh perspective on the very nature of space and time. Imagine the universe as a grand, intricate tapestry woven from the threads of space-time. It's a beautiful idea, but there are knots and tangles we don't fully understand. Black holes, for instance, are like dense, heavy points that warp this tapestry, creating seemingly impossible scenarios. But what if there was a new way to look at it? The Tosh Metric is a modified space-time geometry, a new way to describe how mass and energy curve the universe. Think of it as an upgrade to Einstein's general relativity, but with tweaks that could allow for interesting possibilities. It introduces extra terms into the classic Schwarzschild metric, terms that adjust gravity's behavior at both cosmic and microscopic scales. Here's the simplified equation, where Q and N are new parameters I've been testing. They could represent exotic matter, higher dimensions, or something we haven't even imagined yet. What if we could smooth out those wrinkles in space-time, make sense of those extreme points in the universe? That's where the exciting new idea of the Tosh Metric comes in. Imagine a piece of paper. This paper represents the fabric of space-time. Now imagine folding that paper. The fold represents the way massive objects, like stars and black holes, warp space-time according to Einstein's theory of relativity. The Tosh Metric proposes a new way of folding this paper, a new way of understanding how gravity shapes the universe. This new metric suggests that instead of a single fold, imagine a series of smaller, gentler folds. This subtle shift in perspective has the potential to change everything. Now, does this hold up mathematically? I've spent months crunching the numbers, Einstein's equations, modified but still divergence-free. Singularities. The new terms soften black hole singularities, no more infinite density. Energy conditions. It gets weird. Some classical rules break, but that's where the fun begins. Could this be a loophole for stable wormholes or warp drives? Maybe. But first, peer review, I need your help. Don't worry too much about the specifics of the equation. What matters is that this small change has significant consequences. One of the most exciting aspects of the Tosh Metric is how it tackles the problem of black holes. Traditional theories describe black holes as points of infinite density, places where the laws of physics break down. The Tosh Metric offers a different view. Instead of infinite density, imagine a highly concentrated but finite amount of energy. This new perspective, while radical, eliminates the need for singularities, those troublesome points of infinity that have puzzled physicists for decades. This shift in perspective extends beyond black holes. It suggests that the expansion of the universe, the very fabric of space-time itself, could be influenced by this new understanding of gravity. Imagine a Earth-to-Mars trip in weeks, not months. With Tosh, space-time could be compressed along the path like folding a map. Here's the kicker. Energy cost, still astronomical, pun intended, but finite. Safety, no spaghettification, probably. Science fiction, maybe. But math doesn't lie. Imagine for a moment traveling to distant stars, not in centuries, but in years or even months. While it's still in the realm of theory, the Tosh Metric suggests that such feats might not be as impossible as we once thought. Of course, challenges abound. Harnessing the energy required to manipulate space-time in this way is a hurdle that, well, really dwarfs our current technological capabilities. However, with continued research and collaboration, who knows what the future holds? As someone deeply invested in this field, I spend my days exploring the mathematical intricacies of the Tosh Metric, running simulations, and honestly just dreaming of the possibilities. But this journey is not mine alone. The pursuit of knowledge is a collective endeavor. It thrives on collaboration, on the sharing of ideas. This isn't just a theory, it's a passion project. For years, I've balanced this with work, life, and sleep? What's sleep? Is one possible path to understanding the universe's grand design. If this journey sparks your curiosity, if the prospect of unraveling the cosmos' secrets excites you, then I invite you to join us. Explore the possibilities, challenge the assumptions, and dream big. Share your ideas, your passion, your vision for a future shaped by our understanding of the cosmos. If you're a physicist, programmer, or just love space, let's collaborate. DM me or comment below. Together, we could push this from whiteboard to reality. Please subscribe to the channel, share, and like. Thanks a lot for your time and comments.